All right, we're going to do another word problem balancing here. And again, we start at the left and go to the right and read it like a sentence and just transcribe it. Oxygen gas. So most people are going to say OG, but it's not how the original works. Remember, oxygen does not like to be by himself when he's a gas because he's diatomic. He wants to have two atoms in his molecule. So he's always there with his twin. So O2 gas reacts with, okay, so that means they're being put together, so a plus. Hydrogen gas. Brinkelhoff again. We need to have two hydrogen because when hydrogen's by itself, it wants to be with its twin. And that's going to form water. Now, it didn't give me the state symbol for water, so we're going to assume that they're creating liquid water, unless there's some other indication like temperature or pressure or something else going on that you could see that it would be a gas. All right, and I just drew my little lines in here because I didn't do crisscrossing. I don't have charges or anything else filling it up, so I can just go right to my reactants chart. I only have O's and H's. And remember, no subscripts. Just because they're diatomic doesn't mean you use subscripts because they're going to recombine in a different ratio. And if you put subscripts there, you're not going to be able to recombine in that different ratio. Only polys keep their subscript because of that force field. All right, 2 oxygens on the left, 2 hydrogens on the left, 1 oxygen on the right, and 2 hydrogens on the right. So there's my initial chart. I can see that conservation of mass is not met. I have to do some work to get it balanced. I'm going to start on the right side. Oxygen's a 1. It needs to be a 2. So I'm going to change the coefficient because remember, we don't change the subscripts after we've done this initial sentence. Don't change the subscripts, only the coefficients. So now I have 2 oxygens on the right. 2 times 1, but I also have 4 hydrogens now on the right, 2 times 2. So now I have to go back, and sometimes you have to go back a whole bunch of times until you have it balanced on every element. Hydrogen here has 2, but he's supposed to have 4. So 2 times something is 4. 2 times 2 is 4. Now I have 2 oxygens on the left, 2 oxygens on the right, 4 hydrogens on the left, 4 hydrogens on the right. Conservation of mass is met. I'm just going to add that 1 in there to make it a pretty sentence, and we're done.